Hello friends. So today we are going to discuss the theorem from the chapter similarity. So we have a theorem. Name of that theorem is area of a two similar triangle. So area of a two similar triangle. If we talk about this one, so they have given a theorem statement as a when two triangles are similar. So questions they have given the two triangles are similar, and after that they have written the ratios of the areas of those two triangles is equal to the ratios of the square of their corresponding sides. So we will learn how to prove this theorem, and this one is very easy. Try to understand. I will try to explain you in very simple method. So first we will draw a triangle. So as they have given the two triangles are similar, so first we will make two triangles. First we will make what? Two triangles, and then we will proceed for the proof part. Okay. Suppose this one is one triangle, and let's say this is the second one. This is the what? Second triangle. If I will give name as a P, Q, R, K, L, M. So these are the two triangles, and let's say this is the perpendicular of the triangle, and this one is the what? The perpendicular of the second triangle. So let's say give name X and Y. You can take any name. So I have taken PQR and XY, sorry PQR and KLM, and that perpendicular is PX and second one is what? KY. Okay. If we go in what? The statement, so they have given, very simple, they have given these two triangle PQR is similar to triangle KLM. This one is given. Apart from this, we can write that PX is perpendicular on QR and KY is perpendicular on LM. So as we have in the diagram that PX is perpendicular to QR and KY is perpendicular to LM. So that we have written. So if we go for the statement C, they have given when two triangles are similar. So these two triangles are similar. The ratios of the areas of these two triangles, the ratios of the areas of these two triangles is equal to. So we go for the proof part to prove. So very simple, they have given the area ratios. So I will write area of triangle PQR. This area ratio and area of triangle KLM. The area ratios of these two triangles, see this, they have written the ratios of the areas of the triangle is equal to the ratios of the square of their corresponding side. If we talk about the corresponding sides of these two triangles, so very simple, we can say that this PQ is what corresponding to that is what KL, and QR corresponding to what? LM, and PR is what corresponding to KL. So we can say that the PQ, QR and PR. So PQ corresponding to that is KL, that ratio. QR corresponding to LM, that ratio. But the PR corresponding to KL, that ratio. So these are the ratios, and they have given the ratios of their square of their corresponding sides. So square of this. So we'll dot, right? Square of this ratio. So very simple. In these two triangles, the area ratios of these two triangles is equal to the square of their corresponding sides ratios. So this, we can see this. Okay. If we go for the proof, very simple proof, this one, we will write first. Always I am starting the proof from the given point. So as we have given that PQR is similar to KLM. So very simple, they have given PQR is similar to KLM. The first we will write triangle PQR is similar to triangle KLM, and as we know, when we have two triangles similar, so we can say that the corresponding sides ratios are equal and their corresponding angles are equal. So from this I can write that PQ corresponding to KL, that ratio is equal to corresponding to QR with what? LM, and that ratio is what? PR with KL. These ratios are equal because corresponding sides of similar triangle. We will write as a reason and give equation number 1 to this. And a similar manner, if the sides ratios are equal, so if these two triangles are similar, so we can say that the corresponding angles are also equal. So angle P is equal to angle K, angle Q is equal to angle L, and angle R that is equal to angle M. And we will write this one as equation 2. And the reason for this, corresponding angle of similar triangle. Okay. Now we will go further. So what we can do now? So this is the thing. Okay, they have given the ratios of their areas. So now we will take the ratios of these two triangles. So if I will write area of triangle PQR, so very simple, we know that this area is what? Half into base into height. So half into base for triangle PQR, base is QR and height is px. So okay, if I will write second triangle, that is area of triangle KLM, and for this if I will write the formula, so half into base is LM and height is KY, so we will write KY, and the ratios of the areas of these two become what? The ratios of their formulas also. And this statement is because of the what? Area of triangle formula. We can write this as a reason. If I have taken the area ratios, so we will write their formula ratio. Okay. If we go further, so we can cancel this. This half and half will get cancelled. So at the end, what we get? The area of triangle PQR divided by area of triangle KLM, and that one is equal to QR and PX. This QR and PX divided by LM and KY. So give equation number, we have given equation number 2 to this, so we'll write 3 at this place. Okay, so next step now, what we will write? We will write now, okay, see, if I will see the equation number 3 and the proof part, we have left hand side same thing, that is area of PQR divided by KLM. But we have to convert this right hand side in the form of square. In the form of what? Square. So how we can convert in the form of square? Very simple. We will replace these values. And we will take any one. We get some replacement for that, and we will get what? Any one ratio out of these three. So what we will do from entire proof, see, we have to prove what? 3 things. So we will prove only one thing, and we will write the similarly we can prove these two also. So I am going to prove that equal to what? The ratios of what? PQ divided by KL, PQ square divided by KL square, that ratios I am going to prove for equation 3. So how will we will prove that? See, I have taken now, and we will write now in triangle, I will write in triangle PXQ. If we talk about PXQ and triangle KYL, PXQ